So our next transformation is a reflection, and what a reflection is a flip over a line. A flip over a line. And sometimes it does change when you flip something over a line. It kind of depends on the shape. And then it's always called the image after we flip it. So the first one here is looking at this like moon. And is this moon being reflected over line M? Yes. Is this little symbol here being reflected? Yes, it's kind of being flipped down. What about the letter J? That is not being reflected. If it was, it would have to go the other way, so that's a no. Now there's two main lines that we reflect over. They sound familiar, I'm sure, the x-axis and the y-axis. So here it's saying, if I go back to number 2, is AB a reflection over the y-axis? Yes, because B would reflect to D and A would reflect to C. So yes, this is over the x-axis. What is that? Yeah. The next one, is this a reflection? These two triangles? No, they're not reflected. But this one is, oh wait, I'm back over here. I messed up. This was the y-axis. You knew that. This one's over the x-axis. So you got to make sure you know which one's which, obviously, huh? This is the x, this is the y. And so here's an example of a reflection where the first triangle is reflected. Notice each point, like the A here is 6 units away, so that when I reflect it, the new A is also 6 units away. Same thing for the B, same thing for the C. So whatever this distance is, it's going to be the same on both sides of the line of reflection, we call it. So we're going to draw in some pictures. Reflect the rainbow here over the line. So this rainbow will get reflected and come down here. Your drawings don't have to be perfect. Here's the triangle reflected over this line. Here's this triangle reflected over this line, and then the parallelogram there reflected over that line. Sometimes we're just going to reflect an ordered pair. So if I take the ordered pair 2, 3, and I reflect it over the x-axis, this is the x-axis, where's it going to land? Well, 2, 3 is going to come down here, and it's going to land on 2, -3. And in general, that's what happens when you reflect over the x-axis. The x-coordinate stays the same, and the y-coordinate changes sign. So it went from 2, 3 to 2, -3. If I reflect over the y-axis, now it's going to land on -2, 3. -2, 3. And that happens a lot, all the time, when we reflect over the y-axis, is that the x-coordinate changes sign from positive to negative or negative to positive. Reflect each point or segment over the axis. I feel like there was more here that's not showing up, so I'm just going to tell you, if I reflect AB over the y-axis, AB over the y-axis, it's going to land on CD. And if I reflect AB over the x-axis, which one's that going to land on? Right, that's going to land on GH. So it's very visual, and usually people do really well on reflecting over the x and y axis. The last thing is a line of symmetry. A line of symmetry is a line that cuts a shape in half. Or we would say if you fold a shape over that line, it's the same on both sides. And we're just going to draw in our lines of symmetry. So like here, this arrow, do you agree that that line would cut the arrow in half? What about the triangle? Usually everybody sees that right down the middle would cut the triangle in half, but also if you go through each corner, it would cut the triangle in half. So there's 3 lines of symmetry in an equilateral triangle. How about this square? Can you cut the square in half? Sure. How many ways do you think you can cut the square in half? Seems like a lot. There's actually 4 ways you can cut the square in half. And then here there are 2 ways to cut that shape in half. we did this one for you, so it's like 1, 2, 3, 4, 5, 6 lines of symmetry for the hexagon. How many for the circle? How many ways can you cut a circle in half? What do you think? Oops. Yep, infinite. There are infinite number of ways to cut a circle in half. So this is reflections.